Hello and welcome back to the Cosmic Acad, and in this video we are going to talk on pointers, call by value and call by reference in Go programming. So what is exactly pointers and then call by value and call by reference? We may have heard about this before, you may have heard about this before, but then this term is confusing actually, right? So let me make it very easy for you, and for that let's see how it works. So very first I'm just going to define it. How What is exactly pointers? So pointers is nothing but, let's start imagining a house, okay, and every house has an address, right? So that address tells someone where the house is located, correct? Similarly, in programming, every piece of data like a number or a string or any data type has an address in your computer's memory, right? Whenever you declare any variable, it is going to take space or storage in memory, computer's memory, right? So a pointer is like that address. A pointer is nothing but the address of those variables. All right. So it tells us where the data is stored, not the data itself. It will just give you the address of the data. All right. Now just assume the data is going to be inside your house, right? And the data can be anything. Let's assume TV is there, in television is there in your house. So you have address of the house, and then inside that you have television. So television can be considered, you can consider television as a data. All right. So in Golang, pointers help us work with memory address directly, and we will see how we can use pointers and what is the purpose of using pointers. Okay, so why do we need pointers? So let's consider one more scenario. You have a recipe for cookies. Let's say you created one recipe and then you make a copy of that recipe, all right, and give it to your friend. And then what if your friend changed that recipe? Let's say your friend intentionally or unintentionally changed that recipe, right? So does this change your original recipe? No, not at all, because you created a copy of that recipe which you created before, and then you passed that copy to the friend, right? So any modification which will happen on the copy will not modify the original recipe, because you have that original recipe over there, right? Similarly, in programming, if you send a copy of the data to a function, right, the original data remains unchanged. The original data won't get changed. Whatever modification you want to do on that copied data, you can do that. To make changes to the original data, you need to send the address or pointer of the data, not the copy, right? And similar in case of house and TV, if you want to make some changes to the television, of course you need the address of the house, right? So that is what pointer actually is. It is just pointing to a specific memory address. All right. Now let's understand call by value. So in call by value, a copy of value is passed to a function. All right. And what does that exactly mean? The original data remains unchanged. Whenever we say we are passing a copy of the value, right, copy of the variable, that means of course the data will be there in the memory address, but then you are copying that data and passing it to somewhere in the function, right? In that case, your original data won't get modified, because any modification will happen on the copy, not the original, right? So let's see that in example. How can we do that? So here what I'm going to say is, I'm going to create one function and I will say change value, let's say. So change value, and then I will pass a number in this as a parameter, and then I will do num equals to, let's say, 20 or something, anything you can give. That means you just modified this specific data which is coming as a parameter in this function, right? And I will just say println fmt.println fmt.println, and then I will say okay, that's completely fine. So inside change value function, and then I will say number equals to the number which is coming over here. All right. Let me just save this, and this fmt should be imported over here. So for that I can say import fmt, and let me just save it once more so that it won't throw any error over here. And then I will say I will just use this function over here in the main function, right? So we know that how can we use function, we know that how can we call a function. So by default in Golang, whenever we call a function, all right, the value is getting passed as a copy of the value, copy of the original value. So let's define a value over here. So I'll say okay, value, and then this time value is, let's say 10, and the same value I'm going to pass here in this parameter, right? So I'll say okay, pass this value. Okay, this should be capital P, fine. Now we have passed this value over here, and then finally what I'll do is I'll just print the value here as well, so that we can see if the value, actual value, is modified or not. So this is the actual value, the same value we have passed over here as in function parameter, and then we have changed this value over here inside this function. Now expectation is this value should change, but then by the concept of call by value, this won't change. Why? Because this is just a copy of the value. In Golang, wherever we are calling function, all the data is passing there as a copy of the value. That means we are passing data as call by value. All right. So here what I'm going to do is, okay, that's completely fine, but then here we just need to print the value, the actual value. And here we are not inside the change value, so I'll just remove this. I will say actual value. All right. And let me print this actual value here as well, so that we can see, okay, what was the actual value before calling this function, right? Let me just save it and run this program. So I'll say run, not run, go run main.go, right? So let's see how it works. It's taking bit time. Actually it should happen, it should run as early as possible. That is because my system is lagging maybe, and in your case it should be, super fast. Okay, you can see here actual value when we defined there is 10, right? And then we pass this value to this function change value, and then there we just modified this value to 20, right? And then we saw that value is 20 actually there. But after calling this function, when we are printing the actual value, again we are seeing 10 over there. That means original value is not modified. And why it is not modified? Of course, by the concept of call by value. So whenever this value will get passed inside this function, by default Golang will consider this as a call by value. That means Golang will create a copy of this value and then pass the copied value here, so that any modification we are doing inside function will not affect the original value. That is actually the concept of call by value. Got it? Right? So now we are clear on call by value. Let's understand what is call by reference. So instead of passing this actual value, what we are going to do now, we are going to pass the address of this specific value. All right. So basically, instead of passing a copy of recipe to the friend, I will say, okay, I have that original recipe lying there on the table. So you can just refer to that. You can just refer to that recipe, right? So what friend will do, he will just come and take that recipe, original recipe, and then if there's any modification on that recipe, then of course the original recipe will get changed, and it will change for all whoever going to use that, right? So let's see how we can do that. So this time I'm going to say, okay, change by value, but this time I'm not going to accept a plain integer value. Instead I will say, give me the address. I don't need a value, raw value. I just need the address. You just give me the address of the actual value, and then I will go to that address and take out the values, right? So in this case, we will be having number, but then we cannot say num equals to 20 because this num is no more value. It is actually the address. It is actually pointers pointing to the address. This is called the pointer. All right. And this is pointing to a specific address, right? So now we have the address. Then if we want to modify the value of the specific address, then we need to access the value first, right? We need to go inside that house, we need to go on to the table to change that recipe, correct? So here what I'm going to say, how can we take out that value? For that we need to dereference it. Okay, this is called by reference actually. Then we need to dereference it, and how we can dereference, that concept is called dereferencing. So okay, we will say one more pointer over here, that means this pointer will get dereferenced. Now this will give the actual value, and then we are replacing those value with 20. All right, and then finally we are printing the value, exact value over here. But then this num will again print the address over here. If you want to check, you can check right now. So, or let me just save it and rerun it, then we'll see if that is printing address or the actual value. All right, so here now we can see this change value is actually expecting a pointer address, right? It's just expecting address of a specific value, original value, not the value itself, right? So that means this time this is not going to be a call by value, because there won't be any copy of the value we'll be passing here. So we will be passing address of the specific value. And how can we pass address? So for that, Golang says you just need to write the variable name, and then in front of variable name you just need to use AND operator. This is called AND operator, and this denotes the address of the specific value. So let's say this value is there as a 10 and it resides in your computer memory, and then you are just passing the address of this value to this change value function, and then this pointer will point to the specific address, and finally using this address we are just going to update the exact value. And how can we update the value? Of course we need to dereference the address first, right? We reach around that address, and then we need to take out the exact value, right, from that address. So we are saying, okay, this time we need an exact value, and then that value itself we are going to modify here to 20 or something, whatever you want, right? So now I'm just going to save this, and let's check this if this works. So let me clear this, or before clearing also I can run here and compare the actual result before we run and this time we are running. So we can see here actual value is 10 over here, and then inside function we are printing this num here, right? But then it is coming like some hexa or octal format, right? And why is that so? Because I already conveyed this to you, that this num is no more an actual value, this is the address of that value. So to take out the value from that address, you just need to dereference it. And how can you do that? Similar way, the way you did it here. So I'll just say star num, and then you will be getting the actual value. Let me just save it and rerun. Now you can see actual value was 10. Inside the function we modified the value to 20, but this time we modified the value by using its address. All right, and then you can see here the actual value is also getting modified, but in the first case it was not modified. You can see here it was not modified, it was 10 as it is, right? So that's the concept of call by value and call by reference. By default, Golang won't pass any value as a call by value in the function. We need to accept the pointer. We need to say, okay, you just give me the pointer variable which will just point to the specific address or the location of that specific variable, and then I will be going to that specific address, I will be modifying the original object. All right, if I want to modify something over there, the original value will change. So that is how Golang call by value and call by reference works, and that is exactly what pointers is in Golang. All right, so next what we need to say here is, okay, this way we have used this, and then what is the benefit of using this call by reference? Actually we have call by value over there, then why we need to care about call by reference, right? That's the legal question actually, why we need that actually. So just assume this data is going to contains some space in memory, but this is a single data. This is just a number, right? What if we have n number of data? Let's say we have a map or we have a struct which is going to be, it has actually lot of properties, or it has actually lot of variable inside those struct or the data, sorry, map. So what if we want to pass that data into lot of functions, right? So that means every time when we will pass that, what Golang will do, as per the concept of call by value, Golang will just copy those data, create a copy of those data, and then pass it to the function. That means every time new memory allocation will be there, memory will be allocated for each of the copy in the memory, and then it will occupy a lot of spaces in our memory, and ultimately our application is going to be slow, right? So to avoid that kind of scenario, we'll just say, okay, don't make any copy, because we don't need to make any copy. Just use this pointer variable, and then it will point to the address. And if you want to take out the data, you can just dereference that and take out the data. And make sure if you are going to modify any data in that onto that specific address, then this data will change for all who is going to use this, right? So that is how we are going to work with pointers, call by value and call by reference. I hope it is clear, and if you guys are facing issues or difficulty understanding, let me know in the comment section. I will try to explain this in more easy way and make you understand. So thank you guys, thank you so much. Keep subscribing my YouTube channel and hit the like button, and do share these videos. I will meet you in the next video.